let's move the knife out of directly underneath my hand. That's what I get for eating cheese at the desk. There we are. Interesting choice on their part. So I finally clicked on the ever-largening, ever-embiggening giant banner that says that they're going to force a new stream manager on me. I got the new stream manager. It is very strange. It's entirely focused on raids. I'm not sure why that is. So I went ahead and I disabled a whole bunch of shit and I blocked some of the stuff as ads. And it's clean, but the stream preview is like really tall and narrow. So it ends up putting a little block in the middle that's my stream. You'd think that I miss the health widget. I'm not sure why they decided that we didn't need the health widget anymore. They sort of replaced it with a little bit rate thing in the upper right-hand corner, but I guess this is what we're getting from Twitch from now on. A too cool Roxor black screen covered in purple buttons and giant text begging you to raid somebody. How fun. All right, so what we're going to do today is we're going to do some underwater development stuff. Oh, shit. I don't think that I can simply copy this anymore because now it's dashboard.twitch.tv. I don't think I want to direct people to my dashboard. I think I want to direct people to my channel. Why is it now impossible to just copy paste my channel? There doesn't appear to be any place for me to be able to select my channel. Great. Amazing choice on their part. So I'm just going to go ahead and leave the new dashboard so that I can actually get back to being able to copy and paste my links. I don't know. It's ridiculous to me how every update always makes things worse, no matter what company it is. Streaming on Twitch. They're trying very hard to make it impossible to copy a link to my stream. But after I revert all their updates, I can find it. Here it is. And then again on Mastodon, starting off with my weekly complaining about Twitch. All right, so now that that's all set up, we can get to work. There's got to be a way to get your, why is my session being marked as 000? There really should just be a button or a link that I can just hot copy. It would make sense. What happened to all of my... You know what? I should probably just go to my channel and make sure that it actually doesn't look like shit. The channel looks fine. There used to be a whole bunch of useful shit, but it apparently is not the case anymore. Oh well. Let's continue. Now that we've got the Roxor cool interface from Twitch, the blue banner is gone, and I can focus now. I am easily distracted by things that are trying to distract me, which is why I ad block extraordinarily aggressively to the point where I have ad blocked most of the dashboard on both Twitch and YouTube. So in the past, we worked on some fish and some stuff like that. We have a lot of things we need to do, and one of those things is that our animation system is entirely broken, and I'm not sure why. When I updated to the newest version of Unity, version 13, it snapped my neck and turned off all of my animations. So I'm going to go ahead and look at that right now. That should be fun, right? Debugging animations all day. So the diver animations is right here, and what we need to do is see what those animations actually are. So we're going to drop this animator tab over on the side, and we're going to see whether or not it actually does any of the things that it's supposed to be doing. We do need to completely replace this, so I'm not terribly sad that it's broken, but it is something where I would like it to work. It doesn't appear to be broken in terms of the states executing. There's something else going on where it's not properly working. It's somehow being maybe overridden by something or not applying correctly. I don't know what that would be. The IK stuff is all still working except for the head seems to have snapped. Let's go ahead and take a look at the head. We'll go ahead and figure out what's going on here. Trying to figure out where I put my head tracker. It's not the player controller. It's stored separately somewhere. It might be in the armature itself. That would be dumb, but I have been known to do that. Hand projector. That's not quite it. Mailman is making a ton of noise. Actually, you know what? I had better quickly check and make sure whether I have to go pick something up outside. Nope. It's ridiculously late. That's how it is. Clickety-clickety. There we go. Right. So I don't know where my head... There it is, a head tracker. It's on the head bone. I guess I had to put it on the head bone because I'm using an IK script here. The problem is that the bone reset. So it used to be that when I imported this bone structure, what we would get is a bone that was broken. But then what I did is I updated to like 0.9 or something, and it changed the way that Blender exported bones, or rather Blender, they changed it somewhere, and all of the bones suddenly were oriented correctly, and I no longer had to correct it. Now apparently, maybe some people complained that the bone structures changed, and now Unity is reinterpreting them to be incorrect again. But now it is no longer pointed in the direction it's supposed to be pointed. It's pointed 90 degrees off like it used to be ages ago. I'm not sure why this is the case. It makes it tough. Let's go ahead and just unfix it. I don't think that's going to change anything, but it's worth testing. No, it's the exact same problem. Snap. So, there's a lot of stuff we're going to have to do to fix this, but I have to completely change everything about the rigging on the character anyway. So there's not a whole lot of point to fixing it right now unless I'm going to be fixing it from the ground up, like completely re-rigging everything and so on and so forth. There are a couple of things I'm trying to experiment with in terms of rigging, because I want you to be able to customize your character, and it's something where I'm not sure that I can allow you to customize your character without creating a custom bone rig that will allow you to do it. And that's got some customized elements to it that aren't normally found in game rigs. I'll be putting in, a custom shoulder set rig, a shoulder set bone that doesn't normally exist, which will allow me to scale the shoulders independently, either by moving them out or by scaling up the entire arm. But what I want to test before we get into that is there is a new technique I learned, and while we're here in Blender, or in Unity rather, I'd like to just test and see what sort of behavior we get out of a very specific setup that I've never really tried before. And I can duplicate it right here in the system. So that's what I'm going to do. I'm going to try it out. So the thing that happens is normally when you create bones, you link them in a hierarchy. But it turns out that Blender can do some tricks with non-hierarchical bones, and then when they're imported into Unity, if they're animated in Blender and non-hierarchical in Unity, you can scale the bones, and since they're non-hierarchical, they won't propagate the scaling. So what I'm going to try and do is figure out whether I can do offset scaling via non-hierarchical setup, and I should have tested this before I bothered to do it. So here you can see what I've done is I've scaled it on one axis, which means that I've updated all of these bones to be bent, to be scaled on one specific axis. And when they turn, you can see how it doesn't really work. This is the sort of thing you normally have a problem with. You can see how the scale continues to be in this same axis no matter what. If the bones are hierarchical and you scale it, okay, so it's the same either way. Never mind then. I was hoping that was a way around the scaling hierarchy bug, but it's not. So basically I wasted your time for a couple of minutes there. But the non-hierarchical solution allows me to do scaling if I want to do scaling-based animations. And you might be thinking, why would you want to do that? And I'm sort of thinking that I don't know if I'll need them for the people, but I might need them for things like squids. Rick Metalster says, "Heyo," or rather, I'm not sure whether that's screwed up on my screen or whether his name contains a million garbage characters. My left screen is pretty badly damaged, so I actually don't know whether or not he's spelling his name with garbage characters on purpose or whether that's my screen screwing up. He says he was typing too fast. Oh no, I mean it's garbage characters. Like none of the letters in your red name are actual letters. They're like symbols that vaguely represent the letters. But I don't think that that's the case. Can I pull this onto my screen without revealing anything critical? Yeah, I can. Yeah, okay, so it's actually my screen that was the problem, not your name. I don't know why, but for some reason, only the red characters are screwed up. Everything else, all the white characters and stuff, is fine, but the red characters are chopped into garbage, and I keep the screen around because it's hilarious. So I'm not upset by it, but it might be difficult for me to read people's names out when they're like this. All right, so we're not going to be fixing the character today unless we plan to spend all day at it. It might be worth it, but I'm still trying to wrap my head around whether or not there is a reason to use non-hierarchical bones. I guess I can probably just go ahead and try it, but I want to talk more about these fish. So we're going to do some more fish today, why not? What I did is I created a new, not a dog mug, I created a new procedure, a new baseline for animated fish, which uses a couple of values to that are going to be shared between all fish. And as you can see, they've got a turn value and stuff like that, but they're kind of choppy. You can see how they're kind of ripped apart a little bit. What we're going to do today is we're going to replace the tail waggle priority. Instead of being red, it's going to be UV coordinate minus a certain amount. And the reason for that is because the UV coordinate is always going to be linear. These fish are always going to be plane projected. So that means that I can just use a linear coordinate and it should work fine. So we're going to go down here into the tiny fish shader. And over here, you can see what we're going to be doing. This is the texture coordinate that we're using to determine the tail waggle. And what we're going to be doing is instead of using red, we're just going to be using tail waggle. So if we take a look at where the red is, I think that's it. Okay, so, but the thing about this is we don't actually want to use the texture coordinate in itself. What we would like to do is figure out the tailness of the texture coordinate. And we're going to store that as an offset. So what we're going to want to do here is we're going to need a property that is the tail start line of the fish. And what that's going to have is a 0 to 1 value, and we're going to put it at like 0.5 just for starters. And what we're going to do is we're going to take the v coordinate and subtract this. Texture coordinate does not need to be a float 4. I'm not sure why I told it to be a float 4, except for inertia, I guess. These are actual texture coordinates we're talking about. This isn't us inheriting. Wait, this is us inheriting. This is UV set 2. This is UV set 1. Okay, we're actually working with the real texture coordinates right now, and it's X, not Y. Once that's subtracted, what we're going to do is we're going to remap it. And that's a register local variable. We're going to need that soon, but we're going to need a remap first. And basically, we are going to remap it so that it, you know what, we don't even need to subtract it. We can just directly remap it. If the minimum is this value and the maximum is 1, then we can remap it to 0 to 1 with that in mind, and then we can just clamp it. No, that's comment. I know that there is a shortcut for clamp. I can't remember what it is. I guess there isn't. Whatever. That's going to clamp it from 0 to 1. And that means we're always going to have a 0 to 1 span, but it's going to start at like the middle of the fish. And with that in mind, we can simply register that as a local variable, which we will call tailness. That's not how you spell it, tailness. And we'll just highlight these and then comment them in the tailness calculations. There we go. And then over here, we're going to go ahead and instead of using this, we're going to get the tailness calculations. Is it F? No. I don't know what F does. G. Tailness. Boom. And boom. So all we've done is we've literally just replaced R with tailness. Here you can see we've got the same situation here with the vertex color. Once again, we're just going to stick in tailness. Boom. That will allow us to just use the coordinates that we have set up on our UV map rather than needing to worry about what's it called? Tiny fish. I might have broken something when I clicked F. I'm not sure. We'll find out. It looks like it's busted, doesn't it? Yeah, it's busted. So I did something very basic and busted it. I did this last week too. So let's see. Something has the wrong name. UV base text on line 61. Well, I guess we can just change it to the overlay texture. I don't really know. Maybe I have to switch this back to a float 4? Wait, the main tail waggle actually uses the same process I'm currently doing, doesn't it? So we'll go ahead and just replace this with get local variable tailness. Well, I didn't get a barfing error that time, so one of those two things fixed the problem. Maybe. And no longer weird black-white stuff. They're now properly showing. And you can see that what we've done is we've made it so that their heads waggle, which is exactly the opposite of what we want. Now, the reason it's like that is because we have projected the heads to be on the right-hand side of the UV map rather than the left-hand side. We're just going to go ahead and flip that. We got a couple of things that we're going to try and do with these. It would make more sense. I mean, we could invert it, I suppose, but it would make more sense if they were just pointed the other way. The only reason they're pointed the way they are right now is because the fish texture we happen to have is inverted. Rick Meadowser says they look like eels. Well, they're a very eel-y sort of fish, but right now the big problem is that this is backwards. So we'll just... There we are. Now they're going to look weird because their tails are their eyes are going to be on their tail, but it should be okay. We're looking at the animations right now, not the textures. Well, this is correct, except for, as you can see, the sine wave is backwards. They are, in fact, swimming backwards. They're trying to turn left. That part works okay. But the swimming is inverted. The actual sine wave is passing up the fish rather than down the fish, which should be something we can fix without too much difficulty. Yeah, I do plan to add a whole bunch of undersea creatures. I don't happen to know about electric eels. Maybe. So, main tail waggle. This is what we're looking at here. Here's the animation speed. Here's the time. Then we add in these values. And what we're doing is we're taking the tailness, we're multiplying by the ripple density and the tail waggle magnitude. And I think what we can do is simply also multiply by -1. Which is actually easier to do if I just move all of these down a notch. That should fix it, because we inverted the x-axis rather, and that means that the waves are moving in the opposite direction now. That's a little bit better. That's supposed to be a fairly lazy swim. It doesn't look too bad, but let's go ahead and do some adjusting. You can see that the tail start line is currently set to 0.49. We're going to move it up the fish, because these fish are mostly tail. That's a little bit better. Right now we're squaring the tail line, which means it gives it quite a snap at the end. Let's go ahead and see how that feels if we stop squaring the tail value. Which just means... boop. I had one of those Diet Cokes because I didn't get any coffee today. And my head's kind of buzzing a little bit. I think it might be a different kind of caffeine. I don't really know if this is going to look right at the moment because it's not in motion, so it's hard to see. So what I think I'll do is I will go ahead and replace the current method I have for fish with the new method. So what that means is that down here in our life system, we've got this fish flock, right? Let's go ahead and open that up in our editor of choice, which I forgot to buy again, so I'll have to buy it next time maybe. Grind, grind, grind. There it is. That was slow. All right, you can see how this is listed as a particle behavior right here. What we're actually going to need to do is we're going to need to make it a fish behavior base. Here you can see that the fish behavior base is a particle behavior. So we're not really changing the process much. We're just inserting a new layer between this and that. The problem is that the fish flock already has all of the fish behavior base stuff in it. It's wrong, but it's in it. So what we're going to have to do is gut it and bring it back. So let's go ahead and give it a shot. So when we look at this, we already have things like fish data, and we already have things like this. So when we look at it here, we're going to have some problems. But what we would like to do is keep all of our values in terms of how it actually works, but not screw up the animations. So we're going to be fixing the animations basically. We have our C data values, but we're storing them for some reason that isn't clear. We won't need these because they already exist. So we'll just delete those. Down here in fetch particles, you can see that what we've got is a subtle change. the target position is move target's 0.position rather than whatever it was before. So what we're going to have to do here is when we do our fetch particles here, and we set the target position equal to pos, what we're going to do is we are going to just replace that one value. And to do that, all we have to do is that. Right? Hold on. Yes, that's correct. I'm going to leave this one here in as well, though. All right, so that should change it so that the particles have the correct values in them when we fetch them. Here in update particles, we've got a lot of stuff happening. This includes a lot of C data values. These C data values are the custom data that we're passing into the particle shader. These define things like how flexible the fish is and what they're trying to do and all that jazz. Basically, all of the C data stuff needs to be deleted. So we're just going to delete it. The C data stuff should all be handled off screen, or rather out of the mind of this particular object, by shaboom, by our fish behavior base. So we don't need to worry about the C data being edited here. It's being derived from the fish data values, so we don't need to do anything with it here. However, what we probably want to do is have this happen at the end. Maybe not. I don't know. We'll give it a shot both ways. There we are. So I am not convinced that this is going to work, but let's give it a try. Got any barfing? Well, that was for defining C data stuff. So when we press play now, it should break because the fish that we actually animate are not using the new shader. They're using the old shader, which doesn't understand what the heck it's doing. But they should still be moving around properly. They're not. Oh wait, they are. They're just listed as slow. So you can see that these fish are the ones that we're going to be doing all the work with. They're not really animating anymore. They're doing something a little bit weird instead. But that's something... they actually might still be animating a little bit. Maybe it's not completely broken. But clearly what we want to do is change out that shader for our preferred shader instead. So over here in the level, we've got our fish flock. And down at the bottom, we have our fishy swimmy. And what we're going to do is we're going to switch out the fishy swimmy for the new tiny fish. You know what? I shouldn't have done that. Undo. We're going to just switch out the material, obviously. I don't know why I thought I was doing the other thing there. We just go up to the materials. Fauna. That's fishy swimmy B. Tiny fish. Boom. So basically, the tiny fish has a custom 1 that goes to text chord 0. This is not how we need it to be for the tiny fish. What we actually need it to do is it needs to have a random stable XY and then a custom XYZW. And that way it goes to text chord 1. You see that difference? That way, when we fetch it, we're always fetching from text chord 1. The stable stuff is just there to fill the swizzle. Woo! So this one has a backwards UV map, this model fish, and which is why it is doing the reverse woggle. Let's go ahead and switch over the mesh to the newer fish, which I believe I called like... I've forgotten the name. Sardine? No, it was anchovy. Now, one of the issues is that the anchovy is way, way smaller. an order of magnitude smaller. So we're going to bring the start size up enough that we'll be able to see them. Okay, so the waggle is set to a very, very high amplitude at the moment, but they're definitely being animated. The question is, when they start to try and turn and stuff... Ooh, look at that. Someone's bugging out. I'm not sure what's up with that. Off they go. That's weird. I'm not sure that these fishes are... I guess they are. The turning values seem a little bit strange. They don't really feel like they're... Look at this. What's with these occasional bug outs? That must be the panicked state. The panicked state must be radically over-animated, because I didn't test the individual states. Either way, we've got to come down in here and really, really lower that, that amplitude, because it is way too high. We might also increase the speed. The speed is extremely low, which means it's a little hard to test some of these. So basically the default swim is at 0.5. That's the level of animation that it passes in, whereas the panic is at 2. And apparently I decided at some point that you should multiply the amplitude by the swim amount. And what that means is that the swim amount is, you get the x-axis wobble at 4 times as much, which obviously isn't ideal. If I get nice and close, I can make them panic, and you'll see what I'm talking about. See? Rah! Which is obviously wrong. So what we're going to do is we're going to just revamp that, because we don't actually need the tail to wobble wider. Here, this tail wiggle amplitude, yes, good. Animation speed goes into the time. Multiply, add, append. Main tail turn. We're passing in this value here, V. V is, I believe, the speed of the animation. So V really shouldn't be going here. V should be going here. Let's go ahead and set that up. And what we'll do is this, we'll duplicate this, move it back, because I don't need it to be a bigger tail sweep. I just need it to be a faster, more obvious tail sweep. So we're going to go ahead and put in a multiply right here. Multiply these together. V. That's not V. This is V. And this is going to be, that's correct. Kaboom. Plam. And then this, let's just disconnect it for now. We'll worry about it later. Just put in these. There we go. So that should take care of the excessive tail wobble nonsense. Let's increase the fish speed a little bit. You know, I'm really glad that I decided to stream today, but I should have had lunch. We'll see how long I can last before it just gets to be too hungry. Just double the speed of the fish for now. So now they should be moving twice as fast. Yeah, there they go. Yeah, the turning is definitely wrong. They should only turn when they're turning. They shouldn't turn when they're... Whoa! You see how they kind of snap around weirdly? I'm not really sure what's going on. It looks like they might be stretching on the wrong... What the hell? Did you see that? They kind of snap funny. Clearly there's a bug somewhere. So what I'm going to do is I'm going to place myself in front of some of these people. That's obviously not the animation I want, but I'm a bit perplexed as to what animation it thinks it is. So clearly there's something stupid happening. You can see how the tail flicks to the side and then it kind of ascends into space. The tail turn is obviously incorrect. There's something wrong with it. What I'm going to do is I'm going to disable the tail turn for now, and we're going to see whether or not the tail turn is a significant portion of our issue. Because it could be that there's a bug anywhere in this code, and it's just something where we're going to delete the bits until we find something that works. Rick Metalster says they're drifting. Now, they're not just drifting. They're doing much worse than drifting. They're turning as they accelerate. Their acceleration animation is their turn animation, which is obviously wrong. Let's try that again. We're going to move the player so that I actually am looking the right direction and can see what the heck I'm trying to do. Yep. So I've disabled their turning animations. They're moving a little bit fast for their tail animations, but I can always just adjust that speed. Yeah, their tail animations are ridiculously slow. Let's go ahead and fix that. We can just increase the animation speed. You have to remember that the particle systems are a little bit different, so... Oh, I multiplied it by 0.5. That's why their animations are so slow. Because I added in that swim modifier, and the swim modifier is bringing it down to 0.5. The other problem is that the amplitude, I stopped multiplying by 0.5, which is why the amplitude seems so high. So, just reduce the amplitude, increase the speed. We'll be back where we started, but without the weird bugs when they panic. They're all in sync, which is dumb. So what I'm going to do is I'm going to add in an out of sync element to their setup, which is not too hard to do because we have two random values we can draw from. So we're going to go ahead and do exactly that. Here you can see that we're multiplying, we're adding, and all this jazz. What we're going to do is we're going to add in another add, and that's going to be from this same UV text coordinate set, but the first UV text coordinate set. So I'll just drag this over here. Make this coordinate set 1. Put in a multiply, make it multiply 10 by W. Doop. And we're going to add that in. And basically that's just going to offset it by up to 10 seconds. Someone's stomping their way up the stairs. Rick Metalster says they're waggling too much of their body and they're thin as hell. Well, these are sardines. I forget what they are. They're one of the smaller, thinner fish, and they really are shaped like this. If they are too thin, they're only too thin by a little bit. They are waggling too much of their body, though. What I really need to do is offset the the tail start line based on the amount of effort that we're putting into it. So what we actually need is 2 tail start lines. So we're going to go over here to the tail start line, and we're going to just expand it a little bit. Boom. Duplicate this bad boy. So this is going to be tail start line slow, and this is going to be tail start line fast. And so this will come down to like 0.2, and this will go up to like 0.5. And we're just going to lerp between them. So we'll just move these. Add in a nice fat lerp. And the lerp is going to simply be the amount of effort we're putting into swimming, which is this one, I believe. No, that's a randomizer. It's V on the other axis coordinate. This one right here. There we are. So we'll duplicate that, bring it up. It's V. But in order for us to use it, we actually have to clamp it. That's not clamp, that's comment. Because it's not going to be as nice as you might think. We actually have to remap it and then clamp it. So this is getting more complicated than you might expect, but that's not a big deal. We can just add in more math. So here's our remap. It's not, is it V? It is V. V. And then that's going to be between 0.5 and 2, or maybe 0.5 and 1. I guess we'll leave it between 0.5 and 1 for now. And then we'll clamp it, and that'll be the alpha. And the reason for that is because we want the slow start line to be, well, I think that 0.5 might actually be incorrect. I think we might need it to be, let's not even remap it. Let's just leave it like this. There we go. Because there are Rick Metalster says that I should add a little bit more fat. Right now you're looking at a worst case scenario. I can add more fat. It's not a big deal, but there are things that you can't really tell at the moment because I've got them working in such a weird way to do this testing. You will very rarely be able to look at fish like this. But basically, yeah, that looks really much better. Only problem is that when they go into their panicked animation, there's actually a snap. And that's because we're changing the multiplier on the time value, which means that suddenly the time value changes and they pop to a new set of seconds. They don't animate into a panic animation. They just suddenly transition into a panicked animation, which isn't necessarily bad. It can look a little bit like they're being startled, and that's kind of what I want to do, but I want to make sure it's not super distracting. Because I'm no longer passing in a time value, which means that I don't get to control the delta time directly. Let's let them go around the block a little bit, and you can see how this is more like what you'd be seeing, and you can see how they don't look too skinny when you're not looking at them straight from the behind. Okay, so that snap is a little bit silly. What we can do is change their snap speed, but we're also going to re-enable the turn, the tail turn. First, let's go ahead and make their snap speed a little bit different, because that's turning delay. Let's bring it up to like 25. And what we're going to want to do here is reattach their tail. So this is their tail, and there it goes. So one of the issues I think we're going to have here is that the tail gets added, which means that we do get extra stretch. But I think I can probably reduce that. Let's take a look at this, make sure that is vaguely correct first. The problem is that the tail animation gets pulled even when they're not really turning very much, which means that we end up seeing the fish seem to like be in a turning animation but moving in the wrong direction. They're going to turn around any second here. For some reason, I've got them moving through that big rock. You can see how that one, for example, is turning, even though they're not actually turning. First off, the turning animation is just backwards, so let's invert it, which is not too hard. We just go up here into the shader, or should I change it? I don't know whether I want to change it in the shader or in the fish. I think I'll change it in the fish. But it's also, like, the turning is a little bit too significant. I'm not really sure. It triggers when they're not actually turning. Like, you can see how those guys are turning right. At least they think they are. In actuality, they're trying to turn left, but they're turning really, really slow. So the tails, this wasn't backwards, but the problem is that it's firing really aggressively. I might just have the wrong values here. I might not have it set up correctly. Let's go ahead and set up the turn radius, the turn element, into the luminance, into the emission. That way we'll be able to tell whether or not the fish thinks it's supposed to be turning. Actually, we don't want to do it here. We want to duplicate this and then use this instead. What is that? It was view. And we'll just do a remap. And now they will glow gray when they're trying to turn one way. Let's go ahead and just put in some colors, because that seems like it's going to be really hard to see. So we'll put in a red and a blue. And we'll just lerp between them. So now they'll glow red or blue, depending on which direction they're turning. Rick Metalster says, can he post a fish swimming video? You can, but it's not going to help me at all, because that's not what I'm working on right now. I'm working on getting this debugged, which is a different set of priorities. I've got loads of fish swimming videos. That's not the issue. The issue is that it's hard for me to get them to work because it's hard to see what's going on. These things swim faster than me. That one's trying to turn. But it's not turning, it's going straight. So you can see that these are really strongly triggering their turn, but they're both going straight. So really the problem is that the turn is aggressively firing when it shouldn't be firing much at all. And that means that there's some bug in my core turning code. So when I get the turn, what I do is I take the current position of the fish and I look at where it's trying to go, which is target. So what I end up doing is I take the current position and the target, and I subtract my position from the target position, which gives me a vector pointing towards the target. We also have our current heading, which is this, and that points towards wherever we're trying to go. So I take the current heading and the new heading, and I take the cross product, which gets me a value pointing either up or down. But when I normalize it, I end up always getting either a 1 or a 0. Okay, so I believe I need to reduce this by the the dot product of the ideal heading and the rightness will be 1 if we're going in the one direction. It'll be -1 if we're going the wrong direction. So what I really want to do is take this rightness and then multiply it by the amount we're deviating. So let's go ahead and get that. This will give us a value between -1 and 1, which we want to remap into the opposing value. There is no remap. That's okay. We can do it manually. So it would be deviation divided by 2 would make it -0.5 to 0.5. So we could be 0.5 minus that. I think that that's correct. Let's go ahead and just state it. Debug.log deviation. That's going to be loud. We'll go ahead and give it a shot anyway, though. So basically, we want to know whether or not that ends up being... That should be correct. Yeah, that's correct. I'm not going to bother logging it. And then what we're going to do is... If vector3 ... is less than 0, we're going to want to return deviation. We're going to want to deviation times equals -1. Return deviation. So if it's 0, what happens? It gets divided by 2, and then it's 0.5 minus 2. That's not right. We need to clamp it. Okay, so this is wrong. We need to actually clamp it, so if it's less than 0, it counts as a 0. There we are. This is much easier. So that means that if it's a 0, then it's a 1. And if it's a 1, then it's a 0. So if we are moving straight ahead and the correct direction, then our deviation is going to be 0. And it's not going to matter whether we're trying to turn left or turn right. When we are attempting to turn significantly off course, it's going to matter a lot more. And I think this will work. We'll find out. Now, we should be able to see them glow depending on how much they're trying to turn. And you can see how some of them flick into blue. Those are panicked characters trying to escape from us. But they're not really turning, are they? They're kind of just accelerating. So there is a flick. I see. So one of the problems is that their sudden flick happens when they change targets. And that's why they suddenly seem to vanish, because they're switching from turning right to turning left. So what we actually need to do is store this as a value that gets continually updated. So here is where we set these values. Here's where we get the get turn. We're going to go ahead and try and reuse the last value of the lerp. So we're going to go ahead and use c.x versus this versus time.delta time times 5. Just try it out here. And the basic idea here is... The basic idea here is that we want the... What? That was weird. It must have tried to help me a little bit too aggressively there. What we're trying to do is we are... We are trying to reuse the previous frame's turn amounts, at least somewhat, so that, oh, for fuck's sake. Yes, clearly what I want you to do when I move something is I want you to hide absolutely everything so that I can no longer see anything ever. That's a priority for me. There we are. So, let's try that one more time. Hopefully, these fish are going to not flick quite so fast. That's much better. So you can see they're still turning red and blue, but they're no longer flicking over the course of one frame. But they are still very red and very blue, even though they're not trying to turn. See that? They're not really trying to turn. They're just kind of going straight. So a small course adjustment is still trying to make them do a full effort into their turn, and I'm not sure why that is. These kind of neutrally glowy ones are fish that are not turning or not, they're not doing either. It seems like it's going the right direction now, but it's not activating to the right magnitude. See, look at that. They're all trying very hard to turn. What is the turn factor here? We've got this turn delay. I want to see what that turning delay actually does. All it does is make the turning slower. So, why is the fish... This dot product takes the two normalized values of the heading and the ideal heading, and it attempts to figure out how much it's attempting to turn. If the dot product is 1, that means that the two are lined up perfectly, and it's not trying to turn at all, which is why 1 minus 1 turns into 0, and that means that it's returning a value of 0 when it does its get turn. So, why? What if we were just to multiply it by itself? No, wait, because that would screw up the negative value. Let's go ahead and just see how this works. I've got a strange feeling that I'm not normalizing things correctly. And dot products aren't actually normalized, but they should be normalized when I normalize both of the vectors. See here, look at those reds. You can see those reds down there trying to turn right, even though they're clearly going basically straight. And now we've got a whole set of reds and blues, and I'm not sure... I think that they're turning the correct direction, but they think that they're trying to turn really hard, when in fact they're trying to barely turn at all. And then they snap. And that part seems to work. And some of the time they fork off and they go turning without highlighting themselves as needing to turn, which kind of implies the turn system is completely broken and isn't doing even vaguely the right thing. So these characters should have their feeding habits turned on, so they should try and split off to feed as soon as we reach an area where they... Look at that. Look at they all want to turn left according to them, but they are going straight. Why is this happening? I'm very confused. Admittedly, I'm trying to do something complicated. So now that they're very, very close to me, they should be going into panic mode. They don't seem to be. Maybe I'm not close enough after all. But you can see how they all think they need to turn, and none of them are actually turning. And there you can see they actually finished their turn. It seems like when their target is close, they want to turn more than they do. All I can think of is there must be a mismatch. You know what? Instead of passing in a position, we should pass in a target vector. That's what the problem is. Okay, I think I know what the problem is. So right now we're passing in a position, which is the position of the particle. And we're comparing the position of the particle to the position of our target. That should work. Let's go ahead and just see what happens if we substitute in the full frame instead. It shouldn't work. It should now be very, very broken. Let's find out. To be honest, that seems a lot more accurate. And we still got some reds that aren't actually turning. Weird. Didn't change anything. The problem is that drawing values so I can debug this is excruciatingly difficult. So what we're going to do is we're going to add in a debug drawer. Public void draw gizmo. And we'll say gizmos dot draw line from vector 3 pause from the position to the target. That'll be a line from where they are to where they're trying to go. And the thing is, I think I actually already do that. What did I break? Oh, I added in an extra close bracket, maybe? This is no longer... Okay. I'm not sure when I did that. I must have done it when I did the draw gizmo. And so when I actually do the fish flocking, I should have a draw gizmo. See, here's a draw gizmo setup, right? And what happens is when we draw the gizmo, we actually draw it for all of the move targets, but not all of the particles, because the particles are a little bit expensive. Here's where we draw it for the particles. We do, in fact, draw most of the things I just said to draw. So let's go ahead and try it out. It's constantly trying to open up the temp files. It's not a great habit. So if we wait until they start to change into weird colors, we should be able to determine if there is something screwy going on. So here you can see that they evolve into the blue and the red like so. And then if we look at them in the scene view, those lasers are where they're pointed, and those blue lines are, let's see. So the red lines, sorry, there's now a siren outside my house and I can't focus at all. All right, so the blue is from the position to the target. So those are actually targeting behind them. And then the yellow is where they're currently headed. So the fact of the matter is these are half blue and half red just out of sheer luck because they're actually very close to wanting to go directly behind themselves. The problem is they're not actually turning. They're not actually doing what they think they're supposed to be doing. Instead, they are continuing forward without turning. And there should be some red lines, but I can't... Oh, the red lines are for when they're far enough from the center point that they need to be pulled back together. So the real question is, these fish think that they're going in exactly the wrong direction. Why do they continue to move forward? So I guess the problem here isn't that they're turning incorrectly. It's not that they think they're turning incorrectly, it's that they are turning incorrectly. The actual turning calculation is correct. It's just not being properly used. Let's go ahead and go over here and delete this. And then we'll go back over here. We're going to go and take a look at that turning code and see why it is being so impolite. So here's the update. We go through all these particles. We add in some noise values. These noise values veer off in some cases. We panic if we need to panic. The new heading is the fish data minus the current position. See? So this is the exact same thing that we're doing when we're doing our turn, right? When we do our turn calculation, we use this exact same code. We pass in the position. We do target minus position. The heading delta is the new heading's magnitude less than fish speed. So if the heading is nearby, we move at 1/5 the normal speed. That's what that says. The new heading is then boosted so that it is moved further away from the center of the fish ball. That just makes it so that these kind of move in and out of their fish formation. So then what we do is we take a dot product between the heading that we already have and the new heading, and we move it so that it is between 0.333 and 1 instead of between -1 and 1. But that's not correct, is it? This is the problem. The dot product is not between 0 and 1. It's between -1 and 1. Let's see if that fixes the issue. I'm not sure what idiot presumed that it didn't go below 0, but that idiot caused some problems for us. No, they're definitely not turning correctly, though. Look at that. What the hell's going on? Look at that. They're supposed to be turning around, and they're just absolutely refusing. I think that the problem here is that what we're doing is we're taking this heading, and we are lerping it towards the new heading, which means that instead of turning, we're just reducing our heading. So if our heading is backwards, it takes a long time to reduce our forward heading enough to start pointing backwards. And that also creates that flip because it goes from pointing forward to pointing backward in one frame. What we really need to do is if our heading is less than 0, we want to make sure that we do some aggressive turns. So if dot is less than 0, then we're going to want to fake our heading. And what we're going to do is we're going to take this new heading and we're going to add in a certain amount of either rightness or leftness, depending on whether we're trying to turn right or turn left. I guess we can just use the turn data for that. So if fish data a.turn pause, then we want to new heading plus equals vector 3, not vector 3.right. It is okay, so this math needs to be a little bit more interesting. We've got a forward heading and we've got a backwards heading, and we're trying to determine whether we need to turn right or turn left. What we need to do is reverse one of those headings so that they're lined up and then subtract them. So let's take new heading, and we want to flip it across, mirror it across the fish. If we reverse it, then it'll be pointed forward in the opposite direction that we want to go. That'll work okay. So we're going to go ahead and subtract it. So now dev is pointing forward rather than backwards and off to the opposite side. So then we can say that dev equals heading.normalized minus dev.normalized. And what that'll be is that'll be a value pointing to the right if we were trying to turn right. And so then what we do is we add that to our new heading. And that's just so that we can get the dot working, right? And then we'll recalculate the dot product. The reason I keep rolling in and out, by the way, is that it used to be that Unity would take quite a bit of time to compile. It seems to have gotten a lot faster at that, so I'm not sure why I keep doing it. Old habits. So here you can see it's still giving us that issue, but they are turning around much, much faster. It looks like I have them going in the wrong direction. That's interesting. Let's go ahead and just invert this. I think that I simply have it backwards. Of course, one of the problems is that this is going to, well, it doesn't matter. If it's backwards, that's the problem. Nobody's turning. Okay, so that just didn't work at all. So if we take the current heading and vector3.up, that'll get us the rightness of the fish. So that's what we'll do. So dev equals vector3.cross vector3.up and the heading. And then we're going to say if fish data a.turn pause is greater than 0, then we want to invert this. And then we're going to add that into our new heading. New heading equals new heading.normalized plus dev.normalized. No, wait, we'll just make it dev.normalized. Just completely change it. And then we'll do this dot product crap. Oh. Let's see if that has any sort of work. Doesn't appear to be doing anything. So you can see that it's lowering their forward motion. Those yellow lines aren't extending, they're retracting. And then when those yellow lines actually finish retracting, they snap around 100%, which you'll see any second here. Oh, they've still got a bit of time left. But either way, what we're trying to do is get those yellow lines to move considerably faster. So when we're trying to get the existing heading to turn, I thought that this would do it. I've changed it so that the new heading is pointed off to one of the sides. That I don't even care which side it is at this point. And what should happen is it should lerp between the fish data and the new heading based on the fish speed and the dot product. divided by the turning delay. You know what I'm going to do? I'm going to go ahead and debug this. Let's see how it looks. We can just draw little red lines to tell us the exact same thing we already know. And see where we're going wrong, because obviously I screwed it up at some point. So if we take a look at these fish, let's wait until they turn silver for a second, or red for a second here. There we go. So when we take a look here, we've got blue lines, yellow lines. So these blue lines are pointing downwards. Downwards because they're trying to move down towards their target. The leftness and rightness of their turn should be largely irrelevant. But in this case, I can see that what's actually going on here is that they are thinking that they're trying to turn, even though in reality it's a vertical turn. I may have to flatten the headings on the Z plane in order to make the turning calculations work. But at this point, it's not the bug that we've run into just yet. This isn't part of the issue that we've seen. Let's go ahead and fix this issue first. So here's the problem. We need to flatten the ideal heading and our current heading. So in theory, that will flatten it. I'm presuming that, I think that this might be the wrong, I think it has to be Y, not Z. Yeah. So in theory, that will keep it from saying that it's trying to turn when in fact it's only trying to go up or down. So we're just going to wait until they start to show their colors. There we go. So you can see that they're starting to show their colors. This fish thinks it's supposed to be trying to turn really hard, but in fact it's only trying to turn a small amount. So I'm not sure where it's getting this idea that it's supposed to turn really hard. But you can see this red beam is going off to the right, which is correct. It's simply that right now, that red beam is not important. So I'm not sure why. I do have a thing where it prevents them from moving vertically. Let's go ahead and just reduce that. I specifically screw up the Y value when I'm doing this here. There it is. See that? Yeah. So you can see that these are pointed almost directly in the correct direction. These are like dead on. Despite that, it seems like it's wanting to turn. It wants to turn quite a bit. But this is like they're the same vector. They're super close together. The dot product should be basically 1. So what is going on? So we go over here into the turn. This is just entirely debugging. It's 4 hours of debugging, which is exactly what all my viewers want. I can tell because they all left. Over here, what we're doing is we're taking the ideal heading and the heading here, and we're getting the deviation. And we're trying to tell whether or not the deviation is high or low, and then we subtract a value. So it should only be bright red when the dot product is close to 0 or negative. But in order for that to happen, the two headings have to be perpendicular. It could be that this is getting past the wrong position, or that I'm an idiot. Yeah, turns out I'm an idiot. So we're going to try that again without the stupid. I changed that to test something, and it turns out that I forgot to change it back. All right, so hopefully some of these bugs will start to be resolved. Okay, so you can see that this is a really, really bright blue swarm. And what we've got is we've got these fish that are moving forward but want to turn to the right. They want to turn to the right in a mass. Unfortunately, blue is turned to the left. And you can see these little red lines pointing off to the left. So in theory, these actually know which direction they're trying to turn, but in practice, they're actually being influenced to turn the wrong way. And I think that's something where, once again, I just didn't actually turn the turning properly, and they're all inverted. So we're just going to invert the turning. That makes a lot more sense. Now blue is actually trying to turn left and red is trying to turn right. I can tell by the fish I've panicked. But we're having the same issue where they're all going that way and they want to turn right? Which is at least good. They're trying to turn the correct direction. These red lines, I don't even think you can see these red lines now that I'm thinking about it on Twitch, but there are red lines pointing to the right of each of these fish, which means that they are receiving the correct instructions to deviate to the right. The problem is they're not actually turning, which means that I probably just have an error in my turning code somewhere, like a special case that I thought at when I made it was bright. So the Perlin noise, what this does is it actually pushes us to move into some other location if it's specifically very, very high. That won't affect our heading at all. It'll just change. It'll change where we're trying to go, but it won't actually change our heading. New heading then happens here where we get our target. This is all correct. This heading delta, where we get how fast we're moving, shouldn't influence how fast we turn. Then we add in our new heading gets added in. This might be it. Let's go ahead and just hide that out for a minute and see whether, how could that be it? Because that won't be it. That's false. I just made something up and it didn't matter at all, because that shouldn't. Well, I don't know. We'll see in a minute here. Yeah, it didn't do anything. They're not turning. All right, so this isn't the issue. And I know it's not because I override the new heading. So here is where I actually set the new heading to that red line, which is off to the left, or off to the right, rather. And I believe that it's the same in both places. Just let me double check here. Yeah. So I get the normalized value. I get the new dot product, which I shouldn't even bother. I should just make it equal to 0. Then I clamp it between, make it equal to 1. Because what I'm actually doing is I'm making it so the fish when the fish are close to being pointed the right way, I want them to point the right way a little bit more aggressively. But similarly, when I have them pointed the wrong way, I want them to point the wrong way less. I want them to switch over. So what we're getting here is the center delta. That shouldn't change too much. That should change... Why this shouldn't have any center delta. Okay, it doesn't. So this is delta time times fish speed times the dot product, which is now between 0.3 and 1, divided by the turning delay, which is a large number, admittedly, but it shouldn't completely prevent the fish from turning. Then the new heading is then set up as this, which is then set straight into the heading. So maybe that reassigning of the dot product was the problem. Maybe it's this really, really high fish turning delay, which I made high when I was misunderstanding something. So maybe it doesn't need to be anywhere near that high. Okay, so almost. Let's try that again. There's clearly a point where it stops making sense, and we're going to try and track down that point and see what the heck's going on. So we'll wait until they start to turn red. There it is. So obviously what they're doing is they're trying to turn towards that blue line, but this yellow beam is getting in the way, and the yellow beam is their current heading. Notice that it's not normalized. That was on purpose, but it might have been a mistake, because I think what's happening here is it's lerping between an unnormalized forward value and a red line out to the right there. And it's just not dragging very fast. So what happens if I make this dot product like 3, which is obviously just totally cheating. But I want to see what's going on here. I don't really understand why they're not turning. Hello? Okay, so what should be happening is they should be turning towards this red beam. See this redness? You can't see it at all, can you? This red line here that you can't see on Twitch. This yellow line should be moving towards it. And it is, but it's like super duper slow to the point where I don't understand what's going on. Let's go ahead and make this 30. I want to just see whether or not I even understand how it's working. Because it might simply be that the fish turn speed is way too slow, but it might also be something more complex that I don't actually get. Okay, so now what we've got is this fish here. Let's take a look. He's going that way, but he wants to go that way. It's not turning. It's shrinking, but it's not turning. Here's where I do... Oh, you know what? It might be this. No, wait, that can't be that. So the new heading is equal to the current heading. And the new heading... Why don't we just try and... Let's force it. Let's just force it. So the heading is going to be normalized, and hopefully that we'll see at least a little bit of difference. Oh, well, we're definitely seeing a much better performance. Okay, so me keeping an unnormalized heading was the issue here. Yeah, look at that. Now they still have this point. You can see how they're kind of not really turning properly, and then suddenly they just kind of snap. Some of that's okay, but I don't want it to be too fast. So let's go ahead and bring this dot back down to 1. I think 30 is a little bit too high. And I think that the turning delay might be okay. So clearly I tried to do some stuff that didn't actually end up working out, and that ended up causing me some bugs later on. So here you can see how then when they turn, they do that flip. You can see how they sort of turn, and then they flip. And what that is they're turning towards the 90-degree angle, and then they're flicking. And that's not what we want. We don't want that flick. So the reason that's happening is because it goes from being a dot product of below 0 to a dot product of above 0. So what we're going to do is we're going to just make this new heading merge with the normalized heading. And we're going to go ahead and multiply it by 1 minus the dot product. We know that the dot product is negative. So a -1 would mean that we need to really focus on this. So just negative dot, I guess. So as it approaches 0, it'll work less and less aggressively. Hopefully that will fix some of our turning around issue. Snap. What are you guys doing? Okay, so here you can see some fish that are trying to turn. And what's going on is that they are pointing forward. Those yellow lines point forward. But they need to turn right. And they've got this right angle that they're doing at. And you can see that this heading is moving pretty aggressively towards that angle. But it's not really going very fast. It's just going a little fast. And then once it gets a little bit closer to lined up, at some point they flip. Also, their tails are pointing the wrong direction. That's interesting. So they're not actually turning in the direction that their tails think they're turning. So that means the animation is backwards. Those are well behaved. So let's go into the animation and we'll just invert the tail here. So what we're going to do is Rick Meadowser says, like the animation stops. Well, the animation for the turn isn't supposed to last more than a few frames. Their turning is really weird. It's like super slow sometimes and super fast sometimes. See, that's too fast and this is too slow. Okay, so those guys were animated just right. But there's an edge case where I can't tell what's going on, but they're clearly not being animated correctly. And I just inverted the tails to see whether or not that made it feel a little bit better, and it didn't seem to help very much. So, pause. Let's take a look at these fish frame by frame and see what the heck's going on. One of the problems is that there's just so many fish, it's a little hard to tell. So the fish are getting a little bit redder, which implies that they want to turn a little bit. Any second now, they should realize that they're close to their current destination and should start to flip to their secondary destination. So here you can see they're starting to turn. They're all starting to point upwards. Why? Why are you pointing upwards? Your destination is below you. So that's probably the bug. The bug is that they are all raising their heads and then they panic. And you can see how they quickly flip and start to point to the new destination. So when they switch destinations, that's when you get the sudden flip, which isn't necessarily terrible. It's a little bit too fast, but I can slow it down. The real problem is these people who are refusing to turn. They're pointing upwards, And when they do start to turn, they turn super duper slow. So I think what might be happening is that the heading assignment needs to be normalized right from the start. So when we try and figure out the new heading, we just always want a heading that's normalized. But the problem here is that there are some other things that don't make sense. Like, why was it raising its head? Why was it starting to point upwards? This doesn't have any... Well, it might have some up values to it. It shouldn't, though. I didn't see any sign that it did in the actual code. Ah, for fuck's sake, I pressed the wrong button. Alright, let's go ahead and just move the game window over here so that we can have it playing off to the side while I can actually see the fish. So here come the fish. Pause. So these are our fish, and at some point they're going to start to error. So here they are. You can see how they're starting to turn their noses up here. So they're trying to go down, but they're not going down. They're going up. And I think that what's happening is... Yeah, you can see how they go above the median line. So it's not that they're attracted to that red line of ours. There's something else going on where they are inverting their y-axis for some reason. And it doesn't happen to all the fish. It only happens to the fish on the left-hand side. Ah, I know what the problem is. It's the noise offset. Turning's too fast, but that's definitely better. So what we are doing right now is we are rearranging this so that it goes to up to 0.3 here. What we actually want to do is bring it down to like 0.1. We just don't want it to be at 0. I think the best way to do it would be to clamp it. So dot equals mathf.clamp 0.1, except for we're not clamping 0.1. We're clamping 0.05 and 1, so that when we're lerping between two radically different values, we don't lerp quite as aggressively. So that should work. The other thing we want to do is we do actually want them to deviate based on their offset position. We just don't want them to do it very aggressively rather, if they are close. So what we're going to do is we are going to divide the new heading boost by how far they are. See, here it is, new heading dot magnitude less than fish speed. So I already did that, but then I changed the way that new heading dot magnitude actually works. So what we're going to do, new heading dot magnitude is actually still correct because I don't normalize it yet. So heading delta needs to be lerped a little bit differently than this. What we're going to do is we're going to do mathf.lerp. No, we can't lerp it. And what we'll do is we will simply I don't want to call it range because that's probably used somewhere else. We'll use heading delta again here. And then we'll say heading delta. Yeah, we'll just clamp it up here. Mathf.clamp. Why does it do that? .clamp. And we'll clamp it between 0 and fish speed. And the value needs to be in the front. There we are. That'll give us a value between 0 and fish speed, where 0 will be if we're within fish speed, and fish speed will be if we're more than twice the fish speed away. And with that in mind, we should be able to divide by fish speed. Why don't we go ahead and just new heading.magnitude divided by fish speed. -1. There, that makes it a little bit easier. So now what we can do is our heading delta is between 0 and 1. It's going to be 1 if we're more than 1 fish speed length away, and it's going to be 0 if we're not. 0 if we're less than 0. So that should give us a lot less deviation as we are approaching a point of interest. That's not too bad, but that snap is still too fast. So I think that the issue here is that I'm still setting the point value. Yeah, here it is, dot equals 1. We actually just want to set this to 0. I think that'll fix our sudden snap problem. Rick Metalster said at some point, much better. Yeah, as I was saying, I wasn't making a bad animation on purpose. I had a bug in my animation, and I didn't really know what it was. Obviously, there's plenty of room for polishing these animations, but what you saw before was just absolutely wrong on accident. And it's definitely a little bit more like what I want. Let's go ahead and examine it up close. Make sure the tails are going in the correct direction, because it's quite possible that I have them backwards, their animation. I think I do. No, they might be right. They're right. They're just not very realistic yet. All right, let's do it one more time. This time we're going to take a frame-by-frame close look. So here's all of our fish. Anybody plan to turn anytime soon? Oh, they're turning now. So what we're going to see is whether or not their tail turning is in the correct direction. And it's in the exact wrong direction, so... Oh, no, wait, is it? I actually can't tell. I think it's in the correct direction, but there's something else going on there. Either way, one of the things we've got to do is in our shader, we've got to go ahead and fix up a couple of small details. Right now, when we have our main tail turn, it affects the x-axis only. We actually need to pull it forward on the z-axis as well. So basically what we're going to do is we are going to multiply this by -1. and hit the Z. And what that'll do is it'll pull the tail forward. Maybe negative 1 is fine, yeah. And that means that when they turn, they won't elongate quite as much. We could do it on both axes if we would prefer. But also, this needs to be not multiplied. It needs to be absoluted. And then multiplied, obviously. And it might be that we want to actually do that to this line instead. We'll know in a second here. Oh, crap, I won't be able to see shit. Rick Meadowser says something about at first it is. Yeah, so the tails are definitely behaving a little bit strangely. And I don't know. We've got two pieces of the tail code running, and I think maybe they're interfering with each other a little bit. Okay, so any second now. There we go. So here you can see a fish. It is clearly turning the wrong way. See that? Also, the z-axis is backwards. So let's invert both of those. Just keep inverting shit over and over and over until you accidentally get the right values. That's my secret to success. So this is actually just going to be multiplied by 1, and then this is going to be multiplied by -1. That's actually already, so just multiply by 1. There we go. Recompile it, and then hit play. Let's take a look. Boom. So here you can see they're now turning with their tails in the correct direction. Their tails are bending. That's not right, so we're going to want to go back into this and square their tail value to the point where I think it might be better to square it over here instead. So we're just going to multiply it by itself. We could also use the power operator. I guess it doesn't matter which one we do. By squaring it with itself, we won't have to do that squaring anywhere else. I'm not sure we do, though. No, we haven't squared it anywhere else. So now that it's properly squared, we shouldn't get any more bendy tails. They should be wiggly instead of bendy. Come on, somebody. Turn. I wonder if there's like a shortcut key. So here we've got a fish that's trying to turn. Let's see how it evolves. Clickety, clickety, clickety. It slowly turns red. And you can see that it flicks its tail like that. The problem is that we don't have the swish that we normally get. There we are. You see that flick? That's sort of what I want, but I may have to adjust the way that it works a little bit more. Let's see how it looks in person. Let's slow the fish down just a little bit because it's hard for me to catch them. They're a little bit too fast. I'll be stopping the stream very soon, so if you've got any questions, now would be a good time to ask me. So, as you can see, the fish tail isn't turning at the same rate that the fish turns. They're completely independent. They're turning in the correct direction, but the actual tail turn itself is not right. You know what? It seems like the tail is... Oh, you know what? This is in absolute X. Fuck. Got to think about this. I think what's happening is that the tail turning is actually being done in world coordinates rather than local coordinates, but that can't be the case because I'm specifying it in local coordinates. Let's just double check that. Local. So it might be that it's not. See ya. Well, I gotta stop now too. All right. See you around, everybody. I'm gonna stop for the day.